So once data is obtained, we're going to be talking about ways that we can display different types of data using tables, graphs, and things like that. So when we're working with a lot of data, it would be kind of useless to just list it all out. So instead, we often use what's called a frequency distribution, and that's going to list the observed values by the amount of times that that value occurs. So we're going to look at an example. Maybe we have a hot dog vendor in New York City that's recording the number of hot dogs he sells each day at his cart. So this is the result of his data, and it's listed in order for us. So you can split up a frequency distribution in a ton of different ways. Maybe you just do it by the single number. So you'd start at 15, the next group would be 16, 17, 18, and so on. But in this specific instance, so each of these rows is going to be 1, 2, 3, 4, 5, 6, 7 pieces of data, and there's 4 rows. So in total, there are 28 data values. So again, you can do a frequency distribution just by the single number, so 15, 16, 17, 18, and so on. But also you can create groupings. So especially if your data is pretty spread out, it would be a really big chart to go from 15 to say 1,000 in a single grouping of 1. So instead, maybe you do buckets of a different size. So in this case, my first grouping is I sell 15 to 17 hot dogs. So there's 3 possibilities in that case, 15, 16, or 17. My next grouping would then start at the next number because I don't want to start at 17 because then I'm double counting. So my next amount of hot dogs I can sell is 18. And then the one thing is I want to keep it the same. So 15, 16, 17 is my first group. 18, 19, 20 is my second group. So they each have 3 within it. And then you continue that pattern from there. The most amount of hot dogs I sell is 27. So I'm going to stop my bucket when I reach that end value. So just going through and counting up, looking at my first group of 15 to 17 hot dogs, there's 1, 2, 3, 4, 5, 6 data values that fall in that group. So in my table, my frequency is 6. Moving on to 18 to 20, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values in this grouping. So my frequency is 11. 21 to 23 is just 1, 2, 3. 24 to 26 is 1, 2, 3, 4, 5. And then finally 27 to 29 is 1, 2, 3. So if you go through and you add all these up, 6 plus 11 plus 3 plus 5 plus 3 again should give you that grand total of 28. And indeed, if you plug that into your calculator, you'll see that's the case. So just adding them all together is a really quick way to check that you didn't miscount, especially when you're looking at an image online. Really easy to miscount, okay? So that's our frequency distribution. Now, also associated to this is something called a relative frequency distribution. And relative is always going to be basically a size comparison. So instead of just listing the frequency like I have here, instead I'm going to find the percentage of data that falls into that category. So I still need my frequency distribution, and then I'm finding a percentage. So filling in these numbers, we had 6, 11, 3, 5, and 3 for my frequencies. So I want to figure out for the relative, we had 6 out of how many that fell into this category. So in total, there were 28 pieces of data. So if I'm looking at what percentage fell into the 15 to 17 range, all I'm going to do is take that portion and I'm going to go ahead and divide it by 28. And what this does is it gives you a decimal. So just pay attention to the homework to see how many decimals you have to round out to. But this gives you the decimal 0.214. So if you want a percentage, you can either just do times this by 100, or the other thing you do is you just move that decimal 2 places to the right. So it's 0.214, which means that 21.4% of data fell into this range. Now I really just continue that process. Here, 11 out of 28 fell into this category. So if you divide that, you would get 0.392, which means 39.2% of data fell into this category. Okay. Now this symbol here, just because I forgot to mention that, this means approximately. So obviously if you do 6 divided by 28 in your calculator, it continues on. It's not a stopping number. So to just say that it's about equal to this, we use the squiggle equal sign. And then from here, I'm using solid equals because 0.214 is exactly 21.4%. But still overall, you'd say it's approximately 21.4%. For my next category, 3 out of the 28 data fell into this group. So as a decimal, that's 0.107. And again, as a percentage, you times by 100 or move the decimal place 2 to the right. So this is 10.7%. Then finally, this category is 5 out of 28, which is 0.180 when you round, which gives you 18.0%. And then finally, this category, we already did 3 divided by 28, it's 0.107, which gives us 10.7%. Okay. So when you round, what you're going to do is you're going to look at the next number, and if that number is 5 or higher, you then bump that digit up. If it's 4 or less, then you just cut it off. And then to check that we kind of rounded everything correctly, if you go ahead and add all of these values together, it should account for 100% of your data. So your total on this should add up to 100%. If you add it up to like 99.8, that means you probably just rounded somewhere incorrectly. Likewise, if you went a little bit over, you just rounded a little bit incorrectly. So these are our 2 main types of distributions we're going to be seeing that we're going to create. A lot of times the groupings are already going to be done for you, so it will give you the categories or the ranges themselves. But I do still want to go over just the rules we have for grouping this and then some of the key terminology for it. So the first data is that all of these classes should be the same width. So again, if I go back to this data, the values that fell in here are 15, 16, and 17, 3 possibilities. 18 to 20 is 18, 19, 20, 3 possibilities. Then 21 to 23 gives you 3 possibilities. And so on from here, 3 possibilities, 3 possibilities. So I want to make sure that everything is exactly the same width. I'm not making one group larger than the other. We need the buckets to be the same size. The other thing I want to make sure doesn't happen is that there's no overlap. So I don't want to end this bucket at 17 and then start my next group at 17. Because then when I go to count how many 17s there are, well, you're going to put them in both of these, and that's a bit of a problem. And then the last thing is that every single data value should belong to exactly one class. Classes meaning these different values. So you need to start your buckets low enough to get the smallest data value, and you need to keep going until you get that highest data value as well. I don't need to put any buckets before this because 15 was the absolute smallest data value I had. So I didn't need to include the classes prior. And likewise, I don't have to go past 27 because that's my maximum data value. So those are the 3 things that we have to keep in mind. So another example, if you're grouping data by age, you could use these as your classes. So 0 to 9 years old, 10 to 19 years old, 20 to 29, 30 to 39, 40 to 49. A common misconception with age data is they usually do like 0 to 10, 11 to 20, 21 to 30. You got to be a little bit careful there because those buckets are actually not the same size. So if you think about the ages 0 to 9, your possibility is you're 0 years old, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's actually 10 ages that fall into this category. There's 9 right here, plus this extra one. So 10 different data values. If I go into the next grouping, I'm just going to do it for this one, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and that's where we end. So in that case, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values here. Okay. So every single class has 10 values and they do not overlap. So this starts at, or ends at 9. This one starts at the very next value, 10. 19, then 20. 29, then 30. 39, then 40. And you'd keep following that pattern. So every single data value will fall into one of these categories. These values that start the different classes are the smaller, so these are called the lower class limits. The values that end that grouping are the higher values, and we call them the upper class limits. Okay. Then our class width, because remember we said these should all be the same size. This one is a common mistake. A lot of times people define the class width, will just look at that and say, okay, well the width of that is 9 minus 0, it's 9. The width of this is 19 minus 10, 9. 29 minus 20 is 9. However, that's actually not the class width because there are 10 data values here. So the way we actually find the class width is we subtract the first lower class limit from the second. Really, you can pick any 2 consecutive ones. So if I take 10 minus 0, that gives me 10, exactly how many values are in that group. Same thing if I took 39 minus 29, gives me 10, exactly the number of values within there. Or if you do 20 minus 10, it's 10. 19 minus 9 is 10. So it's really as long as you pick 2 consecutive lower class limits or upper class limits, you'll find the class width. So just in this example, 2 consecutive limits are 10 and 0 to give you a class width of 10. The next 2 are 20 and 10. When you look at their difference, it still gives you 10. If I pick the upper class limits, the first 2 are 19 and 9. Their difference is 10. The next 2 are 29 and 19. Their difference is 10. So this class width is 10, okay? The next other important identifier for a class, because maybe I don't want to write the full range in there, is called the midpoint of a class. Which is also called a class mark. Is going to be found by taking the lower and the upper class limits, adding them together, and then cutting it in half. So basically, I'm looking for the number that's directly in the middle of these two. So in this case, the class mark for 0 to 9 would be you add these together, divide by 2. So 9 divided by 2 would end up giving you 4.5. That's the age that's directly in the middle. Okay. And then the very last terminology is going to be the class boundary. So class boundaries are the numbers used to separate the classes, but without the gaps that we create by these limits. So just to kind of go back up here and show you, 9 and 10 are going to be that separation. So my class boundary is really the midpoint of these. So it would be 9.5. Basically, that's going to be the cutoff. If you're below 9.5, well, then you're in the first category. If you're above 9.5, your age gets rounded and puts you into that next category. So just in that case that you have kind of funky data like that. Okay. So what we're going to do is we're going to specifically talk about graphs that we can display with these frequency distributions. So once I have the data collected and organized, what's one way that we can kind of visualize what's going on? So we'll discuss quite a few, but the first types we're going to discuss are histograms and frequency polygons. Now it depends on the book you use, it depends on the software too, as to what's going to go at the bottom, but they're both going to be ways to display this. The histogram is basically just a bar chart. So you use a bar to display the frequency of the class, and instead a frequency polygon is going to connect the dots and create a line to kind of show you what's going on. So what we're going to do is we're going to look at a specific example, and we'll kind of use this for all the different types of displays and graphs that we're going to use. So we'll refer back to the same frequency distribution. But we've got 35 people that attended a symphony, and these are the ages of those 35 people that were chosen at random. First thing we're going to do is we're going to construct a frequency distribution with a first class of 20 to 30. So in this case, the buckets were already given to us, but just to kind of show you how you would go about creating this. So my first group is 20 to 30. So my next one has to start at 31. So you can think of a couple different ways. The difference between these is 10. So the difference between these should also be 10. So from 31, I add that number. The end of my group should be 41. My next one then starts at 42. So again, I add that number of 10. This is going to be 52 for that end grouping. Then the very next stage is 53. And then adding 10 to that gives me 63. And that gives me enough groups because 57 is the final value. The other way that you can go about this is, since your next group has to start at 31, you can look at the difference between these two, which is that class width. So I'm going to go ahead and find all the key pieces of information just so we get used to it. But the class width in this case would be 31 minus 20, which is 11. So the other way you can find this information is you add 11. So you add 11. Add 11, add 11. Add 11, add 11. And all of those get you those end caps. So in this case, when it's nice values, it's not a problem. But if your class width, say, is something like 0.5 or 0.8 or 7.3, that one's a little bit more difficult. So going about just adding that class width each time might be a little bit easier for you. So I'm going to start by going ahead and calculating the frequencies for each of these. So starting with 20 to 30, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data that fall into that grouping. If your data is not organized in numerical, like ascension or descension, probably put it in increasing and decreasing order. It'll definitely help you out. My next group is 31 to 41. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces of data. Then we've got 42 to 52. So 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. And then my last group is 54 or 53 to 63, and that is 2 pieces of data. So this is my frequency distribution. Again, if I wanted to find relative frequency, then all I would do is take each of these and divide by how much data there is. And thankfully they told us that it would be dividing by 35. Okay. Now we're also going to find those other key pieces of information. So I'm going to find the midpoint of each class, because this is also something I'm going to use to make my histogram. So the midpoint, I'm looking for the number directly in the middle. My group is 20 to 30. So we go ahead and add these together and divide by 2. 20 plus 30 is 50. 50 divided by 2 gives me a midpoint of 25. My next group is 31 plus 41 over 2. And that gives me 72 over 2. So my midpoint here would be 36. Next group is 42 and 52. And then we divide that by 2. So that's 94 divided by 2. And that would give me 47. And then finally 53 and 63 divided by 2. Well, that's 116 divided by 2, which gives me 58. So these are the midpoints of each class. The other thing you can notice, to get from one midpoint to the other, you add 11. So plus 11, plus 11, plus 11, you're just adding that class width. Now to find the class boundary. Again, it's basically going to be the midpoint of these two values. So in this case, you would do 30 plus 31 divided by 2. But really, it's the number directly halfway in between. So hopefully you can recognize that's 30.5. My next class boundary is the midpoint of 41 and 42. So halfway in between that would be 41.5. Then my next group, 52 and 53. So that midpoint is 52.5. And then finally, I do have a class boundary for here. So 63, my next one would be 64. So 63.5 would be right in the middle. And again, if you notice, you're really just going ahead and adding that class width each and every time. Okay? So those are the key pieces of information for this specific frequency distribution. Now we're going to go ahead and we're going to construct a histogram and also a frequency polygon. Now, again, it depends just on the book. It depends on the problem. It depends on the software you use, what's going to go on your legend down here. So sometimes you only want a single marker to represent that class. And if that's the case at the bottom, you would put that midpoint or the class mark. So my first group had a midpoint of 25. So 25 is right here in the middle. My next point, again, we add that class width, which is 11. So it was 36, plus 11 is 47, plus 11 is 58. You might also have different graphs that really just do the start and end. So in this case, the start of this group was 30 or 20, and the end was going to be 30. So then that very next group would start at 31, okay? But also this can be a little bit problematic because your next group starting at 31, well, you'd have to make sure there's a gap between the two bars. So also you might put that class boundary right here in the middle. But for this specific example, since I am going ahead and I'm using that midpoint, I'm just going to draw a bar connected up to each other so we can see the clear separation. So my first grouping had a frequency of 10. So what I'm gonna do is I'm gonna go ahead and just draw a bar that takes me up to 10. Okay. Then my next grouping had a frequency of 14. So I can connect these two bars and I just go up to 14. And again, they should all be the same width, but obviously as I'm drawing by hand, it's not going to be perfectly aligned at the bottom. My next class is 9, so 9 is halfway in between these two. So I draw that bar down. And then finally, my last frequency was 2, so I draw that bar downward. And then thankfully, since I'm using an iPad, I can go ahead and shift this a little bit to make it a little bit better. But this would be my histogram. If I want to do a frequency polygon, we really kind of do exactly the same thing. Again, you could put the ranges at the bottom, but I'm just going to go ahead and use that midpoint or that class mark. And instead of drawing a bar for each of these, I'm just going to put a dot for where that belongs. So my age of 25 as my class mark, that group had 10 people. The next group had 14. Then we had 9, and then finally down to 2. And so all I do is just connect those dots to make that frequency polygon. Again, depending on the book and software, you might also see bars that are drawn to the end. And this is really where it gets its name from, because it creates a polygon, which is just a shape with sharp edges. So it creates a polygon with that horizontal axis. But you don't always see that. You sometimes just see the line chart above, okay? So that's our histogram and frequency polygon. The next thing we're gonna talk about is going to be a cumulative frequency distribution. So a cumulative frequency distribution is going to be similar to a frequency distribution, but instead, if you think of the word cumulative, it just keeps adding and adding and adding. Your cumulative grade is what you have at the end of the semester once you have more information. It's going to go ahead and sum up all of the classes before that. So we're going to just do this with an example using that same distribution, the same ages at the symphony. We're going to create that cumulative frequency distribution. So here, my first grouping, the max age is 30. So that's my class, less than 30. So in this case, the number of people that are less than 30 is exactly the number in that first group, 10. My next class ends at 41. So for my cumulative frequency distribution, I want to find all of the people that are less than 41. That includes these 14 people, but also the ones that fall into the prior class because they are also less than 41. So in this case, what I do is I take the first class and I now add the 14 people that fit this category. So the cumulative frequency is 24. Now, if I look at the people that are less than 52, in this case, it's going to be these 9 people plus all of the ones before it. So really, it's the previous class plus these 9 people. So you can do 10 plus 14 plus 9, but really just take the prior class and add the new amount of people. So there are 33 people in total that are less than 52. And then finally, for this last group, this is basically going to be everyone. So you take the 10 plus 14 plus 9 plus 2, but again, that just takes that previous group and adds the new people that fit into it. So there are 35 people that are less than 63, which is the total amount of data. So you can also calculate relative frequencies for this. So the percentage of people that were less than 41 is 24 divided by 35. Percentage of people less than 52 is 33 divided by 25. And then you would keep going like that. So you'd see those percentages get bigger. So it'll no longer total to 100%, but this N category should be 100%. Okay? So the next type of graph we're going to look at is called a stem and leaf display. And this organizes data so that you can actually see all of the data values too. So basically there are going to be two main types of digits. The first one is kind of what it stems off of. The last group is then going to be the last digit. So each value is represented by two groups of digits. The first group is the stem, and then the second group are called the leaves. So it depends on the data itself, how many digits there are, how you're going to go about this stem and leaf display. So in our case, if we look at the data, every single one is 2 digits. So it's really easy to then just split it into the first digit and the second digit. The first digit is going to be that important one, which is our tens. The second digit is then what stems off of the first one. Those are the leaves. So the stem is going to be the tens digit, and the leaves is going to be the ones digit. If, however, I had data that was in triple digits, a little bit hard when you have ages, but just to kind of show you, say this was 154, 157, 126, things like that. But you also had 2 digits. Well, in that case, you would still kind of work with this first one. So the first stem would be 2, but the stem here would be 12. The leaves should be a single digit to make things much easier. So leaves are typically going to be the ones place, and then the remaining digits tend to be the stems. So what I do here is I'm going to go ahead and look at my first digit, which is 20. The first important number is 2. And then I look at my last one, which is 57. The last stem I need is a 5. So I'm going to go ahead and list all of those stems at the front. 2, 3, 4, and 5 are my only options in the tens place. And then I'm going to go ahead and make a bar to indicate, okay, these things on the left are going to be my stems. Okay. Now to say that we have the data value of 20, what I'm going to do in this spot is just put that ones digit. So 20 is my first data value. Well, I have another 20, so I have another leaf of 0. So this tells me I have 2 data values that are 20. Then I've got 2 values that are 23, so I'm going to put 2 3s. So this tells me I have a 20, 20, 23, 23. Then I've got 2 26s, so I put 2 6s. And then finally, my last data value that starts with a 2 is 29, so I end with a single 9. Okay, so I'm just going to put the separation to make life a little bit easier. Those are all of my values that started with a 2. Now I'm going to go through and I need to do all my values that start with a 3. So I'm going to put a breaker in here to know I keep going up to this point. And so starting with these 3 values, we have 3 30s. So I put 3 zeros. Then I've got 2 31s. So I need to put 2 1s. I've got a single 32, a single 33. So I put a single 2 and a single 3. 2 34s. So 2 4s after that. 2 35s. So 2 5s. No 36. Next up is a single 37, a single 38, and then my last 3 ends with a 9. So again, you'd read this as there's a 30, 30, 30, 31, 31, 32, 33, and that gives you all of the data values. Next up, we go through the 4s, and thankfully we don't have as many as those. So starting out, we have 3 40s, so 3 zeros, a single 42, so a single 2, then a single 45, a single 47, and then 3 49s. So we put 3 9s. And then last up, we thankfully don't have as many 50s, so I've got 5 of them. I just need to find those 5 ones values. So we have a 50, 51, 51, 54, and 57. So that is our stem and leaf display. Okay. So you'll see this as a nice way to display all of the data that's there, and it kind of gives you insight. So if you look, if you kind of put this on the side, it kind of makes a bar chart there. So you kind of get some information about that graph. But these histograms are going to be some of the most valuable types of graphs for us. Because when you plot data like this, the shape is actually going to tell you a lot of information about that population. So we're going to look at a couple different types of common shapes, and we'll see some examples of both of those as well, or all of those as well. So that first histogram shape that could happen is you see something that's pretty rectangular. And it doesn't have to be perfect because obviously data is not going to be perfect. But maybe you have some that go a little bit above, a little bit below. It looks pretty even in some places, not in the other, but maybe your histogram looks something like this. It's seemingly that all of the values are happening at the same frequency. So everything's pretty much got an even chance of happening. So it was likely that if you picked a person, they could fall into any of those categories. So a really good example of this is, say you take a standard die. It's got 6 sides. If you roll that die 1,000,000 times, it's likely that you're going to get an equal number of 1s, an equal number of 2s, an equal number of 3s, 4s, 5s, and 6s. Everything happens with the same chance. So out of those 1,000,000 tries, if you were to plot that histogram, it should be pretty rectangular. Now, of course, it's not going to be perfect though, because you could have an uneven amount. Say you rolled the die 24 times. You would expect everything to happen 4 times each. You'd get 4 1s, 4 2s, 4 3s, 4 4s, 4 5s, 4 6s, because that would add up to 24. However, in practice, it could be that you got 12 6s. It's unlikely, but it could happen, okay? So it might just be a little bit skewed depending on how many data values there are. But something that happens with an even chance and long number of trials or a high amount of trials should have this distribution. The second type is a skewed distribution. So we have 2 possibilities. It can be skewed to the right or it could be skewed to the left. And so it's kind of backwards from what you would think skewed to the right would mean. You would think most of the data would be on the right, but basically there's going to be this very long tail of information on this side, on the right side. When you have something that's skewed to the left, well, in that case, that tail is going to be on the left-hand side. So the tail is on the direction of distribution. To think of some examples, Skewed to the right, you can think of annual income for families. Most families fall probably within that $0 to $200,000 income. There are very few families that make over $200,000. However, there are definitely families that make millions, billions. So in that case, you're gonna have some data, but it's gonna be real small amount of people. So most of the population is going to sit here. Okay? So that would be one example. Another example skewed to the right would also be the number of kids in a family. Most people are going to have 0 to probably 3 kids, but there are definitely families that have way more. You think of the Duggars, they got 19 kids. So there are people in that extreme value. It's just there's way less of them. So most of the data is going to be here, okay? The last type of distribution is probably our most important, and we're really going to dissect this near in the future. And that's what's called our normal distribution. So what this is it's symmetric. So basically, if you split this right in the middle, this graph is the same on both sides of that line, okay? And again, it's not going to be perfect, but you're always going to see most of the data is in the middle, and then it decreases this way, decreases this way. So your graph has a small amount, keeps going up, 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 till it hits a max, and then it keeps going down, 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 down. So this is a normal distribution, also called Gaussian. But if you think of the word normal, it's kind of like what you would expect in a population. So really good examples are common traits. IQs should have a normal distribution. You've got an average intelligence rate in the middle, and then you've got people on both ends of the spectrum. So you've got Einstein, who's insanely smart and has a high IQ, and then you have people on the very low end as well. SAT scores, another great example. There is an average for people, and then you get the ones that are scoring perfect, and then the ones that aren't, but there's less and less of them. Height, another prime example. So if you think about the average height for women, it's some specific number. Same thing, average height for men, probably somewhere around like 5'6", 5'8". I don't know the exact number. But most men fall within a certain height range. However, you've got your NBA stars that are 7+ feet. But again, there's far few of them. And then there's far few that are lower than 4 feet. So it's a pretty symmetric distribution, okay? So a lot of data that we're going to work with is going to be this normal distribution. So we'll talk more in detail about this later on. The very last thing I want to do is talk about one more type of graph, and this is called a dot plot. So what this does is it really uses a dot or some kind of counter above a horizontal scale to plot it. So if I have this data here, which are different numbers between 1 and 9, all I'm going to do is add a dot for every single data value of that number. So if I start with 7, I'm going to put a single dot above 7 to say, okay, I've got 1 7. Then I've got 2 8s, so I add 2 dots above 8. Another 7, 1 6. Then I've got 4 9s here. And then a single 1, okay? And again, it really just kind of creates a histogram because it's making that counter go up so you can kind of see the shape overall. The benefit of these kind of diagrams is you can see most of your data is grouped here and the shape that it has. And then you've got this random one off to the side. This helps you kind of identify outliers. So an outlier is something that's just not in the normal. So again, most of the data is clustered here between 6 and 9. And then I've got this random guy over here. This guy's a little bit on its own. probably an outline for the data if I'm looking at measurements. So these are all the different ways that we are going to display data. Of course, there's definitely more than this, but it's the main ones we're going to focus on. You can also think about pie charts. Might want to refresh on those, but we're not going to spend too much time creating them. You will, however, see some homework questions where you have to analyze pie charts. So if you have any questions with that, just let me know.